From the LGN, information continues via the optic radiations to the visual cortex, the site of a great deal of higher-level processing of visual inputs. The cortex, which gets its name from the Greek word for bark, is a folded layer of tissue that covers the cerebrum. The cortex is fundamentally a two-dimensional structure, a bit like a crumpled-up piece of paper overlying the rest of the brain. The cortical sheet itself is laminar in structure. That is, it's composed of layers, 6 in most parts of cortex. Imagine 6 sheets of paper on top of each other. The cortex is about 2 millimeters thick in humans. Each layer of cortex is characterized by different cell types and patterns of connectivity. This layered structure is basically held in common across many different regions of cortex. The visual portion of cortex begins at the back of the brain in the occipital lobe and extends into the temporal and parietal cortices. The first area in cortex to receive visual input via LGN axons is the primary visual cortex, which in humans is located at the very back of the brain, buried in a deep fold in the cortical surface called the calcarine sulcus. Primary visual cortex also goes by the names V1 for visual area 1 and striate cortex, based on the appearance of a dark stripe called the stria of Gennari, which is visible in a sliced-up brain. This dark stripe coincides with layer 4 of cortex, where all of the LGN axons innervate the cortical sheet. Axons from the LGN innervate cortex in an orderly fashion that preserves the spatial XY organization of the retina in the spatial dimensions of the 2D cortical sheet. This orderly pattern of connections is referred to as retinotopy. The best understood part of the visual cortex is probably the primary visual cortex, the first region in cortex to receive visual input. Unlike the LGN, where every layer gets incoming neural input from the retina and sends outgoing axons to the cortex, the primary visual cortex input arrives in very specific layers of the structure. The largest input occurs in the spiny stellate neurons in layer 4, which includes information from the magnocellular and parvocellular neurons in the LGN. LGN inputs to layers 2 and 3 come primarily from coiniocellular neurons in the LGN. Interestingly, in layer 4, the input driven by the left and right eyes remains segregated from each other in the ocular dominance columns, or ODCs. These ODCs are stripes of neurons that respond preferentially to the input from one eye over the other. These columns span multiple cortical layers and are laid out in a striped pattern across the surface of V1. ODCs were very important in early studies of cortical plasticity, as it was discovered that monocular deprivation, for example, patching one eye during development, causes specific columns to degrade, while the non-deprived eye assumes control over the cortical cells. Visual cortex is an exquisitely ordered structure, with many different properties of the visual world mapped onto the physical structure of the cortex at different scales.